Once again, hello. Welcome back to ETM Analytics, where we empower data-driven decisions. My name is Esdras Koome. This is the second and the last bit of multiple linear regression model, where we shall be conducting coding in R. The first step to performing multiple linear regression model in R is by first importing the data. So you can specify the path, or if you're directly working from your directory, you just pass the name of your dataset. So since I'm working directly, I just pass the name of my dataset. Now I'll store my data in an object I will name customer data. Customer data is equals to read.csv. This is the function used to read the data. It's an inbuilt function, read.csv, customer data, customer data, customer data dot csv. It's a CSV. My file is a CSV. And then let's take a view. If you recall at part one of our video, we say that we are going to predict the number of customers registered with respect to public awareness and community awareness campaigns conducted. Hence, therefore, then we proceed to building our model. We first attach our data set to ensure that we have suggestions of the variable names when we type them. And then now we can build the model. Model is equals to LM, which is basically the function that is used to perform all regressions in R. LM, we have our wires customer registered. Customer registered, want to predict customer registered with respect to our public awareness campaigns, public awareness campaigns plus commodity awareness campaigns, and then we have to specify what's our data. Our data is customer data, customer data. So with that one now, to visualize it, we get the summary of our model, the summary of our model. So with this one now, with the summary of the model, what we want to identify is our beta node, beta 1, and beta 2. We are going up to beta 2 because we have two dependent variables and dependent variable. So with this one now, we can check our beta 1, our beta node is negative 9.69, which is significant. From the p-value, 3.05 exponential negative 7 is equals to 0. It's less than an alpha of 0.05 at a 95% significance level. Looking at the public awareness campaigns, the beta 1 is 4.578, which is also significant. Our beta 2 is negative 1.512, which is not significant. The p-value is greater than the alpha. So with that one now, our equation will therefore become y is equals to negative 9.69 plus 4.578 star x1 plus minus 1.512 star x2, or customer registered is equals to negative 9.69 plus 4.578 star or times public awareness campaigns minus 1.512 times community awareness campaigns. That's our equation from the result we found there. And therefore, to look at the amount of variance of y that has been accounted by the two dependent variables, we look at the adjusted r squared. We use the adjusted r squared here because if we use the multiple r squared, we won't have accounted for the multicollinearity that is happening between the two variables, the two dependent variables. And looking at the adjusted r squared, you can see 99.26% of variance of y has been accounted by the two independent variables. Multiple linear regression model has adhered to all conditions for multiple linear regression. We use what we call the diagnostic plots. You can recall this in part one. And to plot diagnostic plots, now we say par mf row is equals to compile to 2. We want to plot them in a single diagram. So that's why I'm using par mf row. And then we say plot the model, and then we plot the model. So our diagnostic plots are already here. We say this, the first one is used to check for linearity, and you checking the residues was fitted. You can see there's a curve, hence conclude that there's a bit of nonlinearity. The second one is used for check for normality, whether the residues are normally distributed. And looking at it, you can see there's a deviation at the end of the tail, hence conclude that our model is not, our residues are not normally distributed. Looking at the scale location plot, we use this one to check for homoscedasticity. And looking at the curve, we can conclude that our data is being affected by heteroscedasticity. The last one, residues, was the leverage is used to identify outliers and influential factors. And looking at them, we can conclude that our data is not being affected by outliers. If heteroscedasticity or nonlinearity becomes a major challenge for your model, consider using other types of models or transforming the variables. Now, the major goal of regressions or any machine learning model is to predict the future. I want us to predict in a scenario where we have 20 public awareness, 20 and 30 public awareness campaigns, and 20 and 30 commodity awareness campaigns. I've created this data, which I will call it test data. I'll call it test data. I want to predict. Now, to predict, I'll say predictions. I want to store the predictions, predictions in the object I'm calling predictions. So I want to predict. I want to predict using my model. What do I want to predict? I want to predict the test data. And so what do you expect? For your expectation, you want to have to see how many number of customers will you have. And when we have 20 public awareness campaigns and 20 commodity awareness campaigns, we expect to have 51 customers. When we have 30 public awareness campaigns and 30 commodity awareness campaigns, we expect to have 82 customers. And that is it for multiple linear regression model. See you in my next video. I shall be discussing about logistic regression model.